For this question here, the setup is we've got a rotating sprinkler fixed at point S, and it orders all points inside and on a circle of radius 20 meters. Point S is 14 meters from the edge of a path, which runs in the north-south direction. And the edge of the path intersects the circle of points A and B, and we've got that information shown in the diagram here. So what we need to do for part A is show that the length AB is equal to 28.57, correct to 4 significant figures. So what we'll do, if I draw a line from S to B, that length is also 20 meters, as it's just the radius of the circle. And if I label the point from the apex here, S, to the base, I'll label that M. And M is going to be the midpoint of A to B, because what we've shown is the triangle ASB is a isosceles triangle. Got two sides the same, A to S and S to B, same length. And in an isosceles triangle, the perpendicular from the apex, so that's S, to the base, bisects the base. So therefore, M is the midpoint of AB. So we'll note that in. So we say let M be the midpoint of A to B. So therefore, A to B is going to equal 2 times A to M. So now all we have to do is work out A to M, and then times that by 2 to get A to B. And we can do that using Pythagoras, because the triangle here, SAM, is just a right angle triangle. So what we end up getting then is A to M is going to equal the square root of 20 squared, subtract 14 squared, which equals the square root of, well, 20 squared 400, 14 squared 196. So we're going to get the square root of 204. It's A to M. And we know 2 times A to M is equal to A to B, which is going to equal 2 times the square root of 204. So just bringing our calculator up to check that we're going to get the correct answer. So we go 2 times the square root of 204. That is equal to 28.5657, and so on. So we'll note that in. So it's equal to 28.5657, which is equal to 28.57 to 4 significant figures.